Okay, I want you to imagine you're walking down the street with your buddy, and all of a sudden you say, "Hey, bro, you know the matrix A equals 3, 5, 1, -1?" And your buddy's like, "Yeah, bro, that matrix is sick. Yeah, but how do I find a to the power of 10? Think about that, man. Am I going to do like 3, 5, 1, -1 times 3, 5, 1, -1? Am I going to do that 10 times? No way, bro. That's a nightmare." But then your buddy's like, "Hey, what if I can take A and write it in a factored form? P, D, P inverse, where D is a diagonal matrix. What about that? But then I could go a to the power of 10 is, well, it's going to be a times a times a, 10 times, right? That still sucks. But now I can use PDP inverse for all of my a's. So I got P, D, P inverse times P, D, P inverse times P, D, P inverse 10 times, right? And that's much better because cancel, 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 cancel. All these things cancel in the middle. And I'm left with P D to the power of 10 times P inverse. And D to the power of 10 from here is just pretty simple to do. I'll just go 4 to the power of 10 because it's a diagonal matrix. I can do it like this. So my nightmare goes away completely. Okay, doing this directly, nightmare. But if I have this factorization here, then this is much simpler. I just go d to the power of 10, and then p and p inverse on the edges. Not a big deal. Okay, so that's what we're going to try to do. This is going to be a process called diagonalization. We are going to try to factor a square matrix like this, and in many applications it'll be very useful, especially when you're doing powers of matrices. Okay, I hope you agree that this calculation is much easier than doing it directly. Okay, so we want to diagonalize. So what that means is we want to find a factorization like this, where D is some diagonal matrix. So let's take this equation and rewrite it. I'll multiply both sides by P, and I get AP is equal to PD. And I'll think about this equation. So let's just say P is 2 by 2, and also A, just for simplicity. So we're going to have A times first column of P, second column of P is equal to the matrix P again, times the diagonal matrix. Now, let's say we don't, A is some new matrix, right? We're going to start over here with a brand new matrix A, and we're going to use a diagonal matrix for D, and we'll use the Greek letter lambda. This is lambda. This is lambda, 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 lambda 1, lambda 2. So we're going to work this out and see what we can deduce. So if I multiply this matrix times a matrix, what do I get? I get A times P1, A times P2, Now if I take a matrix times a diagonal matrix like this, if it were the other way around, if this guy were over here, hopefully you'd agree that the effect of the multiplication would be to take lambda 1 and multiply the first row of P. And lambda 2 would be multiplying the second row of P. Now it turns out that when you have it arranged this way, then it's actually the columns that are being multiplied. So this will work out to lambda 1 is going to hit this column, and lambda 2 is going to hit this column. All right, what's the point of all this? Well, now we have column equal to column. So we get A times P1 is going to be lambda 1 times P1. And we're going to get A times P2 is lambda 2 P2. Okay, take a deep breath. Let's remember what we're trying to do here. This is where we ended up. What were we trying to do? We were trying to diagonalize, right? We were trying to say, okay, I would like to factor A as PDP inverse. And now if I'm looking for P, and if I'm looking for D, as I should be, okay, I'm trying to find P and D that will make this work. Okay, all this nonsense here is to say, well, if I'm looking for P and D, I should be looking at these equations. So, all right, therefore, to find P and D, we should find vectors x not equal to 0. I'm going to explain why in a second. And these real numbers, lambda, such that ax is equal to lambda x. Okay, that's what we found here. Okay, we have the columns of P will be these vectors x, and then these diagonal entries in D will be the lambdas. Okay, so if I'm trying to find D and P, I should focus on this equation. Try to figure out under what circumstances that work. Now I need the x to be not 0. Why do I need the x to be not 0? Well, because the x is going to be the column of this matrix P. So, and I need in this factorization, I need this P to be invertible, right? So I can't have a column equal to 0.